In Lesson 4.2, we're looking at negative exponents, and you'll be able to write expressions using negative exponents and evaluate numerical expressions containing negative exponents. For your note sheet, you have this key concept of negative and zero exponents. Make sure that you fill in the notes with what a to the negative n means. A to the negative n is equal to 1 over a to the positive n. An example, 8 to the negative second power is equal to 1 over 8 to the positive second power. We also see that x to the 0 power is equal to 1, where x is not equal to 0. Please fill those in on your note sheets. A negative exponent is the result of repeated division, whereas a regular exponent is repeated multiplication. This graphic is in your note sheets, and I'd like for you to fill in the numbers. 10 to the third power is 1,000. 10 squared is 100. 10 to the first power is 10. And showing by the repeated pattern here, dividing by 10, we see that 10 to the 0 power is equal to 1. A very common wrong answer is 0. But now that you see the pattern here, 10 divided by 10 divided by 10, 10 divided by 10 is equal to 1. And if we keep with our pattern, when we take 1 divided by 10, we get 1/10, which is 10 to the negative 1. And 1/10 divided by 10 is 1/100th. Study this form, this pattern, on your note sheet as you fill it in, and we'll do some more practicing during this lesson. On your note sheet, the first one we have is got it on page 142, 1A, B, and C. For writing expressions using a positive exponent, we want to make sure to get rid of that exponent by moving it to the denominator. So in the example here, 2 to the negative third power is equal to 1 over 2 to the positive third power. And m to the negative fourth power is equal to 1 over m to the positive fourth power. Try to do 1A, B, and C on your note sheet by pressing pause and working them out on your sheet, and then press play to check your answers. Three to the negative fifth is equal to 1 over 3 to the positive fifth. Y to the negative third is equal to 1 over y to the positive third. And 2 to the 0 is equal to 1. On example 2, it says to write each fraction as an expression using a negative exponent. So if we have 1 over 4 squared, we can write that with a negative exponent by writing 4 to the negative second power. And 1 over 100 is the same thing as taking 1 over 10 squared, and 1 over 10 squared can be written as a negative exponent of 10 to the negative second power. See if you can do 2A, B, and C on your own by pressing pause and working them out on your sheet, and then press play to check your answers. For 2A, the only reason 6 to the third power is in the denominator is because it started off as 6 to the negative third power. So negative exponents don't want to be negative, so then they move either to the denominator or to the numerator, and they become positive. Technically on 2b, you could write 25 to the negative 1 power, okay, and 25 to the negative 1 power is 1 over 25. But if we're talking about perfect squares, 25, the square root of 25 is 5. So 5 to the negative 2 power is 25. And finally, 1 over 27, again, that could be 27 to the negative 1 power, but 3 cubed is also equal to 27. So 3 to the negative 3 power would be equal to 1 over 27. They can be kind of tricky, but I promise we'll work some more of these out during class, and you'll get some practice on your homework. And you also have a brain pop video, a regular video to watch on negative exponents. And you, of course, always have the video tutors that you can watch in addition to this video. For the next one, we have example 3, and we are given some story problems for 3A and B. Take a second to read those and try to work them out on your note sheet. And then when you're ready, press play to see how you did. For 3A, 0.0001 is 1/10,000ths. So the fraction is 1 over 10,000. But 10,000 can be written as 10 to the 4th power. But because it's in the denominator, we can write that as 1 over 10 to the 4th, or we can move that 10 to the 4th to the numerator by making it 10 to the negative 4th power. Okay? And on 3B, 0.00001 is pronounced 1/100,000. So this part should not be new to you. You should be able to write that as a fraction by just counting the decimal places. 100,000 is another way of writing 10 to the 5th power. Okay, but 10 to the 5th power is 100,000. 10 to the negative 5th would be 1/100,000. So the fraction here that we have is 1 over 10 to the 5th. And then we can also write that as 10 to the negative 5th. Again, if you want some more practice with those, you have a video that you can watch, and I promise it'll become a lot more easy as we do more practice problems together. On page 142, I also wanted to look at 143, there's another got it section on example 4. Example 4 is just evaluating expressions that have negative exponents. And so this isn't new to you other than we have negative exponents. Okay, so when you have negative exponents, that's going to apply to just the variable in this case. If it was 4a in parentheses to the negative 5th power, then everything would be raised to the negative 5th power. But in this case, the a is to the negative 5th power and the 4 is just fine by itself. Okay, you do have a video tutor to look at if you want to look through that one. And coming down to the got it section, again, if you want to pause the video and try to work these out on your own, you can. And then press play when you're ready to see the answers. For 4a, m is equal to 4, and 4 to the negative 2 power is the same as 1 over 4 to the positive 2 power. And 1 over 4 to the positive 2 power can be written as 1 over 16. For 4b, only the n is to the negative 4th power. So if I put 3 in for n, I get 3 to the negative 4th power, which is the same as 1 over 3 to the positive 4th power. Now you might be saying, what's going to happen to the 6 and the m? Well, it's a multiplication problem, so I can make each of those fractions by just putting them over 1. 6 times m times 1 is equal to 6m. In the denominator, I have 1 times 1 times 3 to the 4th. And 3 to the 4th is the same as 81, and so I can write that as 81 in the denominator. Now, you actually can still simplify that because 3 is a common factor of 81 and 6. So the simplified version would be 2m over 27. For 4c, we have n to the negative 3, and it's the opposite of that. Okay, so I'm going to save that opposite for my answer. I'm going to plug in n, which is 3. 3 to the negative 3rd power is the same thing as 1 over 3 to the positive 3rd power. And 1 over 3 to the positive third power is the same thing as 1 over 27. And the opposite of that would be a negative 1 over 27. Finally, negative 4m to the negative 2, m is equal to 4, and 4 to the negative 2 power is just like saying 1 over 4 to the positive 2 power. And 1 over 4 to the positive 2 power is the same as 1 over 16. And what happens to that negative 4 out front? Well, negative 4 is just like saying negative 4 over 1. Negative 4 times 1 is negative 4. And in the denominator, 1 times 16 is 16. And we can simplify that to be negative 1/4 for 4D. Okay? Again, the negative exponents really can throw you for a loop, but if you go back to the beginning of the lesson where they showed this table of why negative exponents work the way they do, this is something we're going to really practice this chapter, is understanding the why behind negative exponents and not just memorizing the rules. For lesson 4.2, you have a video on negative exponents that you can watch by scanning the QR code on your note sheet. You also have IXL lesson level K, lesson V3. I want you to get an 80% or better on that. On the back side, or on the next sheet, there is a screenshot of some problems taken from your textbook, and we'll take a look at those together in class. But I would like you to fill in the table on your note sheet. Let me bring that up really quick. You have a note sheet that looks like this, and I just want you to fill those in with the answers. So you could start in column D, because column D is everything to the 0 power, and anything to the 0 power is equal to 1. And then you have positive exponent 1, 2, and 3 moving to the right, and then you have negative exponents moving to the left. So please fill that in as a part of lesson 4.2. And then for the extra problems on the worksheet here, we will go over those together in class unless you wanted to take a look at those beforehand. That should be there on your note sheet, and you can do that again by yourself, or we can look at it together in class. Don't forget to take your self-check quiz and email me the screenshot of your score. And don't forget your IXL lesson V3 and level K to practice your negative exponents. There's the video QR code that you can scan and watch as well.